All right, everybody. So we continue working on our exponential functions, and so what I did is I just grabbed an example of two different exponential decay curves, and you can see that they're both sloping down and to the right. And so what we've talked about is how we can compare these and what those different things we're seeing visually, how they show up in the equations. And so I typed the equations in, but then I just hid them, so you can't see them. So this is kind of like a problem you might see where you're given a graph and you have to interpret some things. So this could be something that's going down over time. So let's say that this is the value of something that you buy. Maybe you buy a new computer, and then over time it gets less and less valuable as it gets kind of out of date. And so maybe the purple graph is a computer that starts up here and goes down and to the right, and the green graph starts here, goes down and to the right. And so what I can kind of interpret here is that the y-axis, the y-intercept, is how much it started out. So I can tell that this computer started, with the day you bought it, it was $1,500. And then if we're looking at the other one, this one looks like it started at $1,200. So it was $1,200 when purchased, when you bought it. But you can see that the green computer starts out less valuable, and then after a certain point in time, the green computer is more valuable. The purple computer graph goes down more steeply and is worth less money over time. I chose some kind of nice numbers, so they actually cross over at a really nice point, 1,900. They're not always going to cross over at a nice point. If I changed my equations, they might cross over at 2.731, some crazy number. But I made them cross over at a nice point just for the purpose of really interpreting what that point means. So that point is common on both graphs. So what that means is right here, I could say that both cost, or I guess both are worth $900 after 1 year. Okay. And then after that point, the purple computer is worth less than the green computer. So what I want to do now is just can we figure out exactly what the equations are, and can we also figure out what that equation tells us about the computer? So let's try to look at some information here. So a lot of so far in this unit, we've looked at just patterns of numbers, and sometimes when I give you a pattern of numbers, you're able to be I see the starting, I see the multiplier, I see the equation. And so what I encourage you to do is, if I give you a graph, I'm just giving you a picture that shows a pattern of numbers. So let's just write down what our purple numbers are. It starts at 1,500, then it goes to 900 when x is equal to 1. Then when x is equal to 2, let's see if I can click on it. When x is equal to 2, come on, give me exactly 2, 540. So I'll write that one down as our next. And I don't really need any more than that because I can tell based on the shape of the graph that it's exponential. So what I know is that I'm going to multiply by something, and I've been using the letter m for that. So I'm going to multiply by something to get from 1,500 to 900. I'm going to multiply by something to get from 900 to 540. So really all you need to do is think about the equation. 500 times what number makes 900? And for some reason, we're in exponentials. People totally forget about all the equations we've been solving all year. This is just a one-step equation. You guys have solved hundreds of these equations. How do you get rid of multiplying? You just divide. Divide both sides by 1,500 to get m by itself. Okay, grab a calculator, unless you can do 900 over 1,500 in your head. Some you can. So if you see there at the bottom of my screen, 500 or 900 divided by 1,500, 0.6. So m is 0.6. And you can double check. If you set up your next equation, you would do 540 divided by 900. And you can see that's also 0.6. And this is the key fact about exponential functions. If you learn nothing else about exponential functions, the only thing that you need to remember is that when you divide consecutive y values, you always get a constant number. Dividing consecutive numbers gives you the same number every time. So you can say that in a different way. You can say the ratio of consecutive y values is constant. That's what it means to be an exponential function. So now I know my m is 0.6. I know that my starting is 1500. My m is 0.6. So I know that the purple graph is y equals 1500 times 0.6 to the x. The x power just tells that you're going to repeatedly multiply by 0.6. And instead of using just the letter y, because I've got two different functions that I'm comparing, why don't we use function notation? It's always good to just remind you of that. It's something that we've learned about. I'm just going to call this the purple function. So purple function is 1500 times 0.6 to the x. Let's do the same game with the green function. The green function starts at 1200. Then it goes to 900, and then it goes after that to, let's click on this green one here. Come on, baby. 675? Okay. So same process here. I know that 1200 times something is 900. How do you solve an equation with times? You divide. So I know that m is 900 divided by 1200. If you divide consecutive y values, that's what you get, is the m value. 900 divided by 1200, feel free to use a calculator, gives me 0.75. So now I know that my green equation, which I'll call g of x, is 1200, starts at 1200, multiplies by 0.75 over and over and over again. Now, when we were looking at an example like this, some people made a really good observation that turns out to be wrong. That's the best kind. So when we were looking at our exponential growth problems, if you multiply by 2 to the x versus 3 to the x versus 4 to the x, the bigger the number you multiply by, the steeper your graph is. And so those people thought, oh, I know that a bigger multiplier means a steeper graph. So they thought that the purple graph should have a bigger multiplier because the purple graph is steeper going down. But it turns out to be wrong. The green graph has a bigger multiplier. Now I want you to think about this. This is a really key important concept. If you have an exponential function, you're always multiplying by a certain number, over and over, multiplying by the same number. So what number can you multiply by that keeps the value the same? The number that multiplies to keep the value the same is the number 1. If you multiply by the number 1, it stays the same. So we're not actually thinking about how big or how small our multiplier is. We're thinking about how far away from 1 is it. And if you think about it from that perspective, the multiplier of 0.75 is 0.25 away from 1. So this is 0.25 less than 1. Whereas the purple function, 0.6 right there, is 0.4 less than 1. And that's the way you can interpret it. You are losing 0.4 of your value in the purple graph. You are keeping 0.6 of your value. That's like losing 40% of your value every year, only keeping 60%. That's why it's decreasing so steeply. Compare that to the green one. You're only losing a quarter of your value. So you're losing less of your value. That's why the green graph is flatter than the purple graph, because it's actually keeping 75% of its value. It's keeping more of its value. And just remember that the key number is 1. If you keep 100% of your value, you have a horizontal line. So the more value that you keep, then the flatter. The more value that you lose, the steeper. Okay, so there you go. Please let me know what questions you got. Happy to help.